Alright, this video is for my last type of chemical reaction, and this is a combustion reaction. Combustion, we're thinking fire. And what do we need whenever we're thinking fire? Well, we need oxygen around. So whenever we're thinking a combustion reaction, we're thinking some sort of hydrocarbon made of hydrogen and carbon plus oxygen. So that's how I'm going to recognize that I have combustion reaction. A hydrocarbon plus oxygen. I could see you wanting to mistake this for a single replacement because we have a compound plus an element, but it's a specialized case here, and when that compound happens to be a hydrocarbon and when that element is oxygen, it's no longer single replacement, it is combustion. And the nice thing about all combustion reactions is that they follow the same pattern. And assuming it's a complete combustion, it's always going to give me the same two things: carbon dioxide and water. We could have an incomplete combustion reaction. And an incomplete combustion reaction is the same thing. We start with a hydrocarbon plus oxygen, but for an incomplete combustion reaction, we'll get carbon monoxide plus water instead. Maybe there's not adequate ventilation, that maybe the fan that's powering it is not working properly, but there's some malfunction in your heating system, and it can lead to a buildup in carbon monoxide levels, which is very, very deadly. These combustion reactions are also one of the most significant to our society right now, because you notice that no matter what we're burning, we end up with the same two ingredients. So whatever this hydrocarbon is, methane, ethane, propane, butane, octane, or even wood, which is mostly hydrocarbons, or coal, no matter what we're burning to fuel our power plants, we're always getting the same things. So whatever you're doing, whether you're driving your car where you're burning hydrocarbons in your gasoline, you're heating your house with wood or coal or oil or natural gas, you're always making carbon dioxide. And that's why we have such a large buildup of carbon dioxide in our atmosphere, which is a greenhouse gas, because no matter what we're doing for a combustion reaction, we're always making more carbon dioxide. Alright, so these are the simplest type, or one of the simplest types at least. So let's say that we have the combustion of methane, CH4. I know it's always going to be plus oxygen, and if you're told that it's complete combustion, you'll say, alright, well, it's going to be carbon dioxide and water, because every combustion reaction gives me carbon dioxide and water. Let's say I'm burning some butane, C4H10. Combustion of butane, let's say I ask for the incomplete combustion of butane. Well, it's still plus oxygen, but instead of carbon dioxide and water, it's carbon monoxide and water. So how do I know I'm going to have a combustion reaction? It's a hydrocarbon plus oxygen. Hydrocarbon plus oxygen. If you're told it's complete combustion, you get carbon dioxide and water. If you're told it's incomplete combustion, you get carbon monoxide and water. And how do you know, let's say on a test, whether it's complete up here or incomplete down here? Very simply, you're going to be told it's complete combustion or it's incomplete combustion. So that's my last type of chemical reaction, combustion.